Okay, so today we're going to talk about ionic nomenclature. Nomenclature is just kind of a fancy word for saying how to name something. And so these are for ionic compounds. Ionic compounds, you can tell it's an ionic compound because you have a metal plus a nonmetal, or a metal plus a polyatomic ion. And I also put a list of polyatomic ions in the course information in Schoology. So if you need to refer back to that, you can. It has the names and the most common ones. I think it has most of the ones that we're going to use. So if you see a compound and this is the case, then you know you have an ionic compound, and you know that you're going to use this kind of naming system. Now, we can also say, instead of a metal and a nonmetal, or metal and polyatomic ion, we can say it has a cation and an anion. Cations are positive, anions are negative. That's all it means, is a positive ion and a negative ion. So the positive ion, the cation, will generally or almost always be metal, the metal, and the anion will almost always be the nonmetal or the polyatomic ion. The one exception to that is ammonium is a positive polyatomic ion. But again, for the most part, the metal is the cation and the nonmetal or the polyatomic ion is the anion. The other thing to note is that the cation will always come first in the name or the formula. It's always written first. The anion will always be written last or second. So whenever you see it, the first thing you read will always be the cation, the second thing will be the anion. So I think probably naming is a little easier than writing the formula. So let me give you a couple examples of Na2S. So we know that sodium is a metal, sulfur is a nonmetal, so this is ionic. So when we name it, naming is pretty easy. You just give the metal its name, and then you change the ending of the nonmetal or the anion to "ide." So that becomes sodium sulfide. And for ionic, remember, we don't really care about the subscript when we name it, because the subscript comes from the charge, and since they all pretty much have the same charge, we don't care. Now, that comes into play, or is a little bit different when we get to transition metals, which we'll do here in a second. So let's do another one. Let's say we have KNO3. So K, I know potassium is a metal. I know that NO3, that's a polyatomic ion. If you look at your polyatomic ion list, you would see it as nitrate. So this is potassium nitrate. Potassium nitrate. Pretty simple. Now, where it gets a little more complicated is when we have a transition metal. Remember, the transition metals are those in the middle of the periodic table, and they can have variable charges. So that means their charge can change. So we have to be careful of what we do with that. So let's say we have cobalt, and let's say we have chlorine. So if we have CoCl2, we know this is cobalt, we know this is chlorine. I know it's going to be cobalt and then chloride. But notice I put parentheses here because remember, when we have a transition metal, one of those metals in the middle of the periodic table, we know we're going to have to put Roman numerals because we need to signify what cobalt is this. What charge does the cobalt have? It could be +1, +2, +3. It could be a bunch of different ones. So we need to signify which one. We can't just say cobalt chloride because we don't know which cobalt it's talking about. So what we do is we look back at the anion. I know that chlorine has a -1 charge. It's in group 17 of the periodic table, so it has a -1 charge. I know that I have 2 of them. So if I have 2 -1s, I know that the total negative charge is -2. The cobalt has to balance that out. So these two added together, the charges of both of them have to add out to be neutral or 0. So if chlorine is -1, I have 2 of them, that's a -2. I need a +2 to balance it out. So that must mean that cobalt is +2 charge. So we would write cobalt 2 chloride. That's how you would name that. Okay. Let's do another one. Let's go with manganese. So Mn, and let's say it is manganese and oxygen, MnO. So I know it's manganese something oxide, because oxygen turns into oxide when it's the ion form. I know that oxygen is -2. How do I know that? Well, it's in group 16 on the periodic table, and group 16, they have a -2 charge. So what does manganese have to be to cancel out a -2? Well, -2 plus what equals 0? It's got to be +2. So manganese is also 2 in this case. So we'd write Roman numeral 2 inside the parentheses. So it becomes manganese 2 oxide. Okay? So that is how you name them. Now, what about if we're given a name and have to write the formula? That's where we're going to have to look at our periodic table. So I'm going to do one on the paper. Potassium nitride, that's the first one. Potassium nitride. Okay. I know that potassium is the cation. I know that nitrogen or nitride is the anion. What are their charges? How do I figure that out? I got to look at the periodic table. I know potassium is in group 1, so its charge is +1. I know that nitrogen is in group 15, and its charge is -3. So then from here, you're going to do where you crisscross. We need to make them balanced, right? So swap and drop, crisscross, however you learned it. The 1 from the K comes over to N. The 3 from the N comes over to K. Becomes K3N for potassium nitride. Again, that 3 goes over to the K. The 1 goes over to nitrogen. Okay, and the reason why we do that is we need to balance out the charge. If I have 3 Ks, each one's +1, that means it's going to be +3. Nitrogen is -3. When I add them together, it's going to give me a charge of 0, a neutral charge, which is what we want. Okay, let's do one more, aluminum sulfide. So that's the next one on your paper. Actually, we'll do 2 more because I want to do a transition metal one. So aluminum sulfide, we have Al +3. How do I know that? Again, that's from the periodic table. It's group 13. You got to look at the periodic table. Sulfur is -2, group 16. Then I swap and drop. Becomes Al2S3. Okay. And again, where it says cation and anion, that column, all I'm looking for is this and this. Okay, cation, anion. All right, let's do one that has a Roman numeral. Chromium 3 bromide. This will be the last one. Chromium 3 bromide. And I know it's chromium, I know it's bromine. This 3 represents the charge of chromium, so this will be +3. I know bromine is in group 17. Group 17 is -1. Again, it's not much different than what we did up here. It's just that now instead of looking at the periodic table to find our charge for the metal, for the cation, we're looking here to find our charge. So from here I just crisscross, becomes CrBr3. Okay? Alright, if you have any questions you can let me know. I hope this helps. Good luck.